My name is Gabriel Peal, and I'm a software engineer at Tonal. But I used to be at Airbnb, where I worked on Android as well as React Native, which is part of what we're going to talk about today. Specifically, we're going to talk about why cross-platform is terrible and you shouldn't do it. But actually, we're going to talk a little bit about why cross-platform is sometimes good, sometimes bad, and why you should maybe do it, depending on the needs of your team. And before we talk more about that, I want to talk about what this talk is not. If you came here to get a concrete answer for whether going cross-platform is right for your team and your company, I'm not going to tell you. If you came here for me to roast React Native for 45 minutes so you can go back to your team and tell them why it's terrible, I'm not going to do that either. Or if you want to balance technical pros and cons of React Native, that's also not what this talk is about. You can refer to our blog posts or numerous other resources online to figure that out. I want to talk about the history of why we did React Native at Airbnb, what it looked like, and then dive deeper into the organizational challenges that we faced scaling a cross-platform team. And then we're going to talk about some of the things we're bringing back to Native to make Native better than ever. So let's go back in time. Let's go back to 2015. Airbnb had an Android team and an iOS team. Two separate teams, two separate code bases. We wrote essentially the same app twice. We had the same features on both platforms, but there was no communication. We added React Native into the code base in 2016. All of a sudden, we had people working across the aisle for the first time. And we had a third platform in our code base, React. So this is really different. This was something new. This really changed the way that our teams were structured at Airbnb. But as you might know, this year, we decided to sunset React Native and go back to two native teams writing the app twice. Some of you might think this is intuitive or counterintuitive, but we'll talk about the details of why this happened. So let's go back to why we did it in the first place. You have to go back to March of 2016. This is when we first introduced React Native into our code base. It was a really interesting time for Airbnb because mobile was becoming an increasingly large part of the business. And we were getting more and more pressure to be mobile first and to make sure we at least had feature parity for everything we had on web. In addition, mobile is uniquely powerful for travelers who are on the road and hosts who want to be responsive to their guests wherever they are. However, we had a huge lack of mobile resources to actually deliver what we wanted to do. In fact, we used to have one small Android team and one iOS team. But in order to become more mobile first, we split that team up so that each team was empowered to work on their platform full stack. The mobile engineering resources were split across the feature teams across the company. Unfortunately, this left entire teams with no mobile resources at all, and we couldn't hire fast enough to actually fill the deficit. At the same time, we had completed our conversion of our website to React. We had probably 10 times the number of engineers at Airbnb who knew React versus Android and iOS. So we simply didn't have enough resources to do what we needed to do. Two of our engineers, Leland Richardson and Spike Brem, saw this as an opportunity because recently Facebook had come out with React Native. React Native allowed you to use React proper on mobile to ship on Android, iOS, and web with the same framework. For the first time, we could tap into some of these resources that we had to help fill that mobile deficit. So they decided to do a pilot. In a couple months, they picked reservation alterations. This was a feature that didn't yet exist on mobile. So getting it out the door was purely a win. And in just a few months, they were actually able to do it. Just getting from 0 to 1 proved a lot of things, though. They had to integrate it into Android and iOS code bases. They had to rebuild experimentation, internationalization, our design language, navigation, and many other core architectural components that are necessary just to get a basic feature working. And it worked. Now, at the same time, we were starting to scale up an entirely new team, a really large team, in fact, and that was experiences. Experiences is the first major product vertical that Airbnb launched since Homes when the company launched in 2008. They had the same challenges that a lot of our other teams had, in that they literally didn't have enough resources to build what they needed to build. So they also chose to use React Native. And in November of that year, they launched it. Now, it was a hard process. We had to build more infrastructure. We had to build basically more of everything. There were a lot of long nights. It wasn't a totally seamless process, but it worked. In fact, it's very possible that if they had tried to do it in native, they wouldn't have been able to launch on time. And this was really challenging because there was a lot of marketing and media and several other timelines that were tied to this November launch. But in order for them to launch on time, React Native did enable them to do that. And over the course of those 2 years, we built a lot. In fact, we built over 220 unique screens in the app. That amounted to about 80,000 lines of product code, 40,000 lines of infrastructure in JavaScript. And the cross-platform dream actually worked pretty well. 95% of our product files for those screens in React Native didn't have a single platform differential whatsoever. We built a lot of the platform differentials into the architecture, the foundation, and the design language that we shipped, but that meant that feature and product engineers could just focus on the product, and for the most part, it worked on both platforms. We also built native navigation libraries that were built on top of UI navigation controller and activities, native toolbars and UI navigation bars in iOS. We achieved some screens with long lists, parallax, but at the end of the day, this entire React Native effort was about 15% of our mobile engineering. At the same time, it was supported by a minimum of 2 engineers who were working full-time on React Native infrastructure, in addition to our native engineers working on Android, iOS, and build tools. So for 2017, I was one of the 2 engineers working with Leland Richardson on React Native infrastructure. In addition to writing the infrastructure itself, we worked with basically every product team that was shipping React Native, both to figure out whether it was the right platform for them. We did many code reviews, a lot of mentorship, and generally had a very hands-on approach to making React Native integrated for all the teams that decided to use it. And at the end of last year, we wanted to get a pulse on how things were going. So we shipped a survey to engineering managers and engineers across the company who had experience with React Native. Of the engineering managers, they were about split 50-50 or 60-40 as to whether they thought that React Native allowed them to ship code faster. But you do have to take this with a grain of salt because it's really hard to actually know this for sure. You never build a counterfactual screen, so you kind of have to go with a time estimate on one side versus reality on the other. So take that with a grain of salt. Now, we got 19 engineers to respond to the React Native engineering survey. Of them, 15 of them had a positive experience, which is actually quite good for something that's moving very quickly and fairly immature as a platform. Of them, about half of them had worked with React before, and about a third on Android or iOS. And more than half of them would choose to use it again, given the chance. However, we were putting a lot of investment into it, but it was still only about 15% of mobile engineering, and that share was decreasing, if anything, because we were starting to hire more and more on the native side. So we wanted to do some math. We wanted to figure out where we were and look at the big picture. And it turns out it's pretty complicated. There's a lot of factors that lead into it, and in fact, if I tried to cover them all today, we'd probably be here until DroidCon 2019. But we did it all internally, we talked about it a lot, and ultimately we decided sunsetting React Native was going to be the right move for us. And today, I just want to dive into the organizational challenges. And the reason I've chosen the organizational challenges is because a lot of the technical challenges are going to vary team to team. They're going to vary based on what you currently have in native, as well as a number of other factors, as well as the cross-platform framework that you choose. However, a lot of the organizational challenges that we faced are going to continue for quite some time, and they don't depend on the actual framework that you choose. So now let's dive in. The first challenge is that cross-platform is just simply really polarizing. Cross-platform frameworks have a long history in the mobile space. People have had a long time and many experiences, good and bad, to form opinions on cross-platform in general. These are separated from the actual technology itself in many cases. We also think that when we're evaluating these frameworks, because we're engineers, we're having a totally rational conversation in which we're pitting the pros and the cons against each other, and we can make a T-chart and whichever one has more wins. But at the end of the day, we're all human, right? We're emotional and rational and some combination of both. And it's really important to remember this. We might have predispositions, and if we aren't aware of that fact, we might spend a lot of time going in circles trying to figure out what the pros and cons are just to justify what we already wanted to know. In addition, early on, if you have a situation that's challenging in which you're trying to pitch a cross-platform framework to a larger organization, you have to be really careful with the first few experiences that you launch. If you have people who are essentially either hesitant or against going cross-platform, if you ship a bad experience early on, it becomes really hard to overcome. In fact, we had one challenging experience on Android at Airbnb with Experiences launch that left a scar on the React Native history at Airbnb forever. And there was one particular screen. It was, we actually recommended that they not do it in React Native because it was a launch screen of the app, and it would be delayed until React Native initializes, which can take several seconds on some devices. It was also a very complicated screen, and there was a lot of time pressure. But they built it as a prototype, and it was ultimately dropped in as a 4,500-line PR, only tested on iOS, and 2 days before the final branch cut. Now, you might be thinking that this would never happen at your company, or you can blame an engineer or the process or something like that. But these things happen, right? You're in the time crunch, you're trying to get something out the door, you have limited hours, limited resources, things like this ultimately happen. It's not really anyone's specific fault. You just have to understand that this is the reality of the world that we live in. Unfortunately, when this launched, it was a subpar experience, and it left a lot of people thinking that React Native wasn't capable of building complex screens. In fact, that screen was ultimately rewritten in native, which further, in the minds of those people, proved that React Native wasn't capable of reaching these high-quality experiences that we wanted. Another thing to keep into consideration is that going cross-platform is not going from 2 platforms to 1. It's actually going from 2 platforms to 3. At the end of the day, you're shipping an Android and iOS app, no matter what. So by adding a cross-platform framework, you are just adding a third framework to your code base. You can't get around the fact that there's still Android and iOS under the hood. And depending on the framework you choose, you're going to have to be hopping between them to different degrees. In addition, not every engineer can reasonably know 3 platforms really well. Like in this room, this is droidcon SF, right? A lot of people in this room are Android experts, and we can think about Android all day, every day for years. We can become super, super good at understanding the nuances of the platform. But if you divide that by 3, there's no way that we can gain the same expertise on all 3 platforms as we can just focusing on one. And then there's just the day-to-day challenges. So it's enough work keeping one platform dev environment set up on your laptop. But with the cross-platform framework, you have 3. You have Android, iOS, and whatever framework you have. And if you actually want to be testing on them, you need those emulators running as well. Now, I know Gradle plus an Android emulator and Android Studio brings my MacBook Pro to a crawl. Now imagine multiplying that by 2 or 2.5. In addition, if you're trying to bridge native APIs, like take geofencing, for example, these APIs were built for canonical APIs on Android and iOS. Now, if you want to bridge those in the React Native world, you have to consider how the APIs work and their nuances on Android and iOS, and then also bridge them in a way that feels canonical in the cross-platform framework that you choose. And finally, sharing state between the platforms becomes really challenging. So obviously, your objects in memory are actually stored in different ways, whether it be the JavaScript VM or the JVM heap or just in memory, native code, wherever your code is, they're different. And you can't just talk over like one-to-one like you would be able to between 2 native screens. You actually have to figure out ways to marshal and unmarshal your code and pass it across. So things that would be really easy normally become really challenging in a cross-platform world. And you run into other little challenges, like take our state management in React Native. We use Redux. In Redux, you have one store, and it doesn't really enforce what you put there. It could be parcelable or not, even though there's not really a good sense of that in the JavaScript world. You could put callbacks or other kind of stateful things in Redux if you choose. Now, sometimes Android will kill your process in the background. It'll ask you to store some of your state in a bundle, and then it'll give that back to you in a new process. Okay? This is really good behavior because it's complicated, but it allows you to return the user to the state that they were previously at without taking up resources in memory when your app is in the background. Now, in a React Native world or a Flutter world, if you have asynchronous communication between your state and the Android world, you can't give Android that bundle back. In fact, even if you could give it back synchronously, you don't know how to serialize a Redux store into a bundle. It's not really possible. And so at the end of the day, we actually had to put in some safeguards in the React Native world to just finish all activities that were in React Native if we detected that it was restarted in a new process. In fact, to date, I don't know if there's a good workaround for this. And if you go to Flutter's GitHub page, you'll see a really, really, really long GitHub issue where they're discussing this, and there are currently no real solutions. It also takes a lot of work to support these cross-platform frameworks. In fact, you're going to be probably working with some teams who are shipping on Android and iOS for the first time. That means that these core infrastructure teams' incentives have to be aligned so that they're willing to invest the time and resources to help mentor, train, and work with other teams that are going to be working in that platform. In addition, these platforms are inherently less mature and faster moving than these decade-old Android and iOS frameworks that we're used to working with. And once you put it in your code base, you actually have to continue to invest in it to prevent it from just falling behind. Not only do you have to bridge all future native infrastructure that your team builds, like let's say they build a new networking library or maybe a new experimentation framework or change the way internationalization works. With every single one of those changes, you have to consider how it works with your cross-platform framework. It's for this reason why I really strongly recommend that feature teams cannot own a cross-platform framework in a larger app. Now, it's really tempting, and I've heard many situations at many companies where one specific team really wants to go cross-platform because it'll make their job easier. But they don't take into consideration the fact that it's not just like a library that you add to the code base. It's an entire framework, and it has to have continuous maintenance over time. In fact, last year, there was one particular React Native upgrade that should have been a simple version bump, but was actually really, really challenging. And this was the first version of React Native that moved from React 15 to React 16. Specifically, React Native is bundled with a specific version of React. And the way that it works internally at Facebook is that it's sort of coupled to whatever the version is on master whenever they cut the React Native version. And for several releases of React Native was bundled with React 16 beta. Now, going beta by itself wasn't really a problem because it was stable enough for Facebook to use on facebook.com. The problem was with our third-party libraries. Most of React Web hadn't yet upgraded to React 16 because it was still in beta. Not just for stability reasons, but just because it's a policy of they only use stable versions. And in your package.json for NPM libraries, you use semver version matching to figure out what versions of React your library is compatible with. Now, React 16 beta is React 16-beta. That explicitly is not matched by the vast majority of third-party packages on NPM. And most of the time, that's on purpose. Now, in this case, in order to upgrade to React Native with React 16 beta, we had to then go and figure out every single one of our dependencies, because most of them were just React Web dependencies, which is, in fact, one of the good things about React Native, but turned out to be a major challenge here. Now, I know Facebook doesn't want to do this again or whatnot, but you are going to encounter these challenges, where imagine if a feature team owned this. It took our infrastructure team over a month to get this upgrade sorted out. And this would be a real burden in a situation where you now have to take that out of your feature development. Testing is also really challenging with cross-platform frameworks. It's a lot of work to properly smoke test everything on one platform, let alone 2 or 3. And when something does go wrong, it can be really challenging to figure out why. In the Android world, we probably have it the best. Our OS is open source. We can step through everything, we can put a breakpoint in one place, and we can probably follow it entirely through to where we want it to go. There's more or less like one main thread, one code path, one language, one dev environment, but it becomes really challenging. Imagine you had a janky view with React Native. You don't know whether that problem is on the React reconciler side. Maybe you didn't implement should component update properly. But in React Native, once React does its thing, it basically sends a stream of your data over a bridge asynchronously to a C++ library called Yoga. Yoga is a C++ layout library that takes Flexbox as inputs, and it spits out sort of like view commands that can be then used on Android or iOS to render native view hierarchies. Maybe the problem's there. Maybe something's not supported correctly, or maybe they have a bug or a performance problem inside of Yoga. Or maybe it's just a problem with the Android view hierarchy, right? It spits out inefficient views, or there's something weird in a particular view it spits out. You don't even have control over that, right? You started in React land, and it went through all these different systems, and then all of a sudden it spit out some like absolute layout in Android. And even if you figure out, okay, it's weird, you have no idea what to do. This is pretty much never a problem in Android, but it can very easily become a problem with these cross-platform frameworks. In addition, we had one situation in which it was one of the most bizarre bugs I've ever worked on. We had an issue where on certain devices, including high-end and usually stable devices like a Pixel, React Native screens would randomly start rendering just white. And once it started doing that, every React Native screen would just be white until you restarted the app. Now, from the React Native side, everything looked fine. Our components were rendering in React. The React Native root view was mounting correctly, and all the state looked like it was correct from what we could tell. In fact, we had several engineers spend several days to try to track this down, and we couldn't figure it out. And this is really challenging because we have a weekly release cycle, and we knew that if we didn't figure this out by the release, it would hold up the entire company's releases. So we actually reverted to a git bisect. This is the only time, I think, in my career I literally couldn't figure out a bug and had to go to git bisect. And it turned out that there was one little commit like a week or a week and a half prior where we removed Fresco initialization from the application on create. So React Native ships with Fresco as the image loading library so that you can load images from the web. But at Airbnb, we used Glide. And this was fine for the most part. Everything worked, right? We replaced all the image components that came with React Native with our own. And we could leverage our own caching and stuff like that as well. So we weren't actually using Fresco in any of our code. But the React Native tutorials had you like initialize it in order to get React Native set up correctly, so we had it in our application on create. It turned out that for some reason, removing Fresco initialization randomly caused some phones to render white on React Native for the duration of an app. I still have no idea why, and if you have any idea, let me know. But this is one of the strangest things I've ever encountered, and it came totally out of the blue and derailed all of our progress for about a week. Now let's talk about the community. These cross-platform frameworks have much younger communities than Android and iOS, which have now been around for a decade. There's over 1 million Android tags on Stack Overflow. Now compare that to 36,000 for React Native or 4,000 for Flutter. React Native has the advantage that some of your problems can be solved with just React questions, but at the end of the day, you do have to consider that these are younger communities. They also move very fast, so when you do find answers, they're often out of date or just don't work in your project for some reason. And the 3-platform challenge also comes into play with open source libraries. Anyone in this room could probably build a super high quality Android library. But try to build an open source library that has code across all 3 platforms. Figure out how to publish it properly and get those artifacts in good shape across all 3 platforms. Make sure all of your developer processes and CI and code reviews and everything is perfect at the same quality level across all 3 platforms. It's really hard. It's not impossible, but it's much harder and introduces a lot of challenges that you don't see normally. And we encountered this on a number of projects, including some of our own, where there would be a library that would work better on one platform than another, or the feature set wouldn't be exactly the same, or the code would just be higher quality on one platform or another. And now let's think about it from the organization. Time in and time out, we kept hearing the same questions over and over again. Should we go native or React Native? This simple question turns out to be super loaded. It ties back into that huge formula we had on the previous, one of the earlier slides. You have to think about the complexity of your screen, who you currently have on your team, who you might have on your team in the future. And there's so many factors that go into it, it's really, really hard to answer that. In fact, you never even know if you made the right choice because you don't build the counterfactual screen. This becomes even harder when you consider it from an engineering manager's perspective. If you're an engineering manager, you often have to make these decisions about who to hire before actually working on the project. So do you hire Android and iOS engineers? Or do you get headcount for React Native or a Flutter engineer? What do you do, right? Especially if you're in a large organization and you have to figure out headcount and how many engineers you need to know these things ahead of time. And these managers often have no experience on mobile or with these cross-platform frameworks. So it puts them in a position where they have to make a really challenging decision that dramatically impacts the future of the team and their capabilities forever. And then from the engineering perspective, if you remember from that earlier slide, we had a lot of React engineers at Airbnb. And we expected to be able to tap into a huge wealth of engineering resources for React Native. We thought that they'd be so excited that they could write code on all 3 platforms for the first time. But we ended up not seeing very much of that. In fact, there are probably a variety of factors, and it's hard to track down exactly why that was. It could be something like engineering managers didn't adjust headcount or resourcing to allow web engineers to consider taking the time to learn React Native and start writing on mobile. It could be due to the fact that mobile is considered a black box by most engineers outside of the community. Most web engineers just see mobile as that thing over there and have never considered the fact that they can actually write code on mobile. That being said, we did do some work with some teams that did tap into their web resources, and it was amazing. In fact, we had one experience where we worked with a team with one of our strong React engineers and had him learn React Native in just a couple of days. And in just a few more days, he built a beautiful screen on Android and iOS using React Native. It had 60 frames per second animations and parallax. It had videos that scrolled and auto-played and auto-paused. It was super performant, and you would absolutely never know whether it is native or React Native. And this was the first code he had ever written on mobile. In under a week, he had this screen written on Android and iOS. He then went back and wrote the same exact feature on mobile web and desktop using React. And he built it in about half the time it would have taken him otherwise, because almost everything he had considered, down to the Redux reducers, carried over almost perfectly. In fact, we think if we worked on this even more, and we actually got to the point where we could actually share Redux reducers and a number of other things, then this process would get even better. So we think that there's a lot of potential there, but it didn't happen automatically. So now let's think about it from the perspective of an engineer. If you're an engineer, and you can build a feature in a week, but because of the overhead of a cross-platform framework, it would take you a week and a half on a cross-platform framework. From your perspective, it actually feels longer. But from the organizational perspective, it's actually less time. So this puts it into an interesting position where you have a situation in which just the perspective of how you look at the time spent on cross-platform varies depending on who you look at it from. And finally, one thing we didn't realize until pretty late is that going cross-platform can have a big impact on hiring. Now, we talked about using React Native fairly openly in the community. However, some people took that to mean that Airbnb was 100% cross-platform. I talked to a number of engineers who didn't consider working at Airbnb purely because they thought we were a React Native shop. Or if you do decide to go 100% cross-platform, once you get to a certain size, you're probably going to want some native infrastructure engineers to make sure that the foundation of your app is solid and to figure out things like releasing and packaging and building the app on a native side. It's going to be really hard to attract the top engineers to work on that little shoehorn part of the company when they can't work on the rest of the app or have no interest in working on the rest of the app. And if you really want to make it a legitimate part of your organization, you really have to loop in recruiting and build an interview pipeline. Right? We interview people for Android, iOS, web, or whatever it is that you have on your organizations. But if you just slap on a cross-platform framework and start using it and never have recruiters look for people and never interview people for it, it becomes really challenging to keep that team as high quality as the rest of the organization because it's starting from a different place. So now that you know about some of the challenges in the history of React Native at Airbnb, I think it's really important for us to take a step back and think about whether sunsetting it means that we failed. We launched experiences and about 220 other feature screens in a short amount of time. We did it with a group of people who couldn't ship on Android and iOS on their own. People who used it generally liked it, and at times it really felt like we were years in the future. In fact, we were doing a number of things in React Native that to this day aren't possible in native and may never be possible. In React Native, you could write a line of code, hit save in VS Code, and it would show up on Android and iOS in a second. You can't even do that on Android or iOS alone, let alone both at the same time. And that really, really worked at scale. With all of the code we had, hot module reloading actually gave us 1 or 2 second build times at scale. We were also working on some features like code push. Code push was going to enable us to push over-the-air updates to fix things like crashes or broken user experiences in the wild. And we had long-term plans to be able to get to a point where we could consider things like continuous deployment on mobile. Now, this is simply impossible with native. You can't do it. But this is something we were actively working towards with React Native. So even though we sunsetted React Native, I don't think we failed. A lot of things launched that wouldn't have launched otherwise. So that's our experience with React Native. But we're not done. And I do want to talk about one more thing. Because we're done with React Native, we're moving on past cross-platform, but there's still a bright future ahead for Android and iOS. But since this is an Android conference, let's talk about Android stuff now. Specifically, I want to talk about a framework and a library that we open sourced recently called Mavericks. Mavericks is built to make writing products on Android super fun, super easy. And I know what you might be thinking now. Now this is just another talk about another MVVM, MVC, MVI, MVP architecture. And it is. But don't take my word for it. I'm really excited about this. Let's see what other people think about it. We did a pilot at Airbnb with about 14 engineers, which mind you is like almost as many that ever used React Native. And they really liked it. In fact, 13 out of 14 of those engineers gave it an 8 out of 10 or higher. The 1.7 is because we didn't have enough documentation, which I think we've now done a little bit better with. And if you look at the pilot, here's a graph of the number of screens built with Mavericks over time. This is all 2018, by the way. So it started in about April. And we started with these 14 engineers who started to build screens with React Native. It grew steadily over time because once they started to use Mavericks, they continued to use it for all new screens. And then it was around this July, early August timeframe in which we opened it up to the rest of the organization at Airbnb. And now its growth looks like that. Pretty much 100% of new features and screens use Mavericks. Everything from a simple hello world to the most complicated screens at Airbnb are now using it because it simplifies everything from simple screens to the most complex screens. So let's walk through it. We're going to build this hello world screen. But I want you to take note, we're building hello world because it fits on a slide, not because it only demos well for hello world. We actually use Mavericks for really complicated screens with pagination and preloading and caching and gestures and everything you can imagine. It works for simple screens and it works for complex screens. But it also pairs really well with another library that we open sourced about 2 years ago called Epoxy. Epoxy, it actually over time has evolved to become sort of React-like in its model. It's built on top of a recycler view, and it helps you take a custom view to build an epoxy model, which is then diffed, and I'll explain that in a second, and then only the changes are dispatched to the screen. So let's take a look at what this screen would look like with just epoxy. That's it. That's the whole screen. You see we have a header, and the header has a title called Hello World. You can go to Airbnb's code base, and you can write these lines of code and actually get a screen that looks like that. But this looks kind of like magic, so let's actually break it down. Let's look at where this header comes from. Fragment, build models, custom view. So here we have a custom view called header. You'll see we annotate header with an annotation called model view. Model view basically tells Epoxy that this custom view should be kind of like a component. If you're familiar with React, it's just like a React component. It will then use this to generate that header builder you see on the left. We can then annotate properties or setters on that custom view, like title here, and that's where title comes from on the left. That's really all there is to it. And with this custom annotation here, text prop, it'll actually generate the Android overloads so that you can use a char sequence or a string resource in your property. Let's make it a little more complex. Let's add Mavericks, because while that epoxy alone is great for static screens, at the end of the day, our screens are stateful for the most part. And that's where Mavericks comes in. So you'll see we're going to start here with a state class. This is enforced to be an immutable Kotlin data class. It has one property called title, which we set to hello world, and it extends Maverick state. We then have a view model. This view model extends the Android architecture components view model and is generic on the state class that you provided. This is really key because it means that the view model, instead of a bunch of live data properties, You just have one single state that you can observe for the view model. One place to go for everything. When one thing updates, you update your UI. And then we pass in the initial state. Initial state is quite interesting here because, as we mentioned in one of my earlier slides, Android can kill your process in the background and restore you in a new one. Now, Maverick understands that Android does this. When Android kills your process and gives you a bundle, it will actually parcel persisted fields from your Maverick state, and then it will restore them as the initial state when you request that view model in a new process. So you no longer have to consider this case. And here, we have a function called getExcited. This is similar to setState in React. We call setState, and we pass it what's called a reducer. A reducer passes the current state, or the this inside of that reducer is the current state. Copy is the copy function from a Kotlin data class, because the this is the current state, and then it returns the new one. So this will update the state by adding an exclamation point to the title. Now, one thing to note here is that Maverick has a threading model built in implicitly. It doesn't really expose it, so you don't have to think about it, but there's a single background reducer thread. So this setState is actually going to be run on a background thread, so if there's any sort of computations or anything like that, you don't have to worry about it blocking your main thread. And you're just observing the state, so you don't really have to worry about when things happen. You're just going to react to it whenever it runs. Now we have a fragment. We've chosen to use fragments because at Airbnb we use fragments. Google's reinvesting fragments, and although they have a long and storied history, they pretty much work, right? People have had problems in the past with fragments, but they've gotten a lot better over time. And again, this reinvestment by Google, AndroidX.fragment artifact, for example, we're really excited about the future of fragments and some of the new things that are going to be built on top of it. And now we have a delegate to get our view model in our fragment. The reason we don't create an instance here is because if you rotate, go through a configuration change, or you come back in a new process, Maverick handles the restoration of your view model, or even gives you the same instance back across rotations. Or if you were to simply just replace fragment view model with activity view model, it will scope it to your activity. So if you have another fragment in the same activity and you request the same view model, you'll get the same instance back. So it makes it really, really easy to share data across fragments in an activity just by requesting a view model. You no longer have to pass arguments or create a custom activity or some control through the activity. And here we have our same build models function from before. It's kind of like render from React. You'll note here that we wrapped it in a with state here. This gives us the current state of the view model. The reason the syntax is like this is because if you have multiple view models, it's varargs. You can do multiple view models inside of with state, and then it'll give you multiple parameters. And then you can render your view based on multiple state. But let's make it more complicated. Let's pretend like we're getting this title from the server. You'll see that from the state perspective, it's a simple change. We replace string with async string. Async is a Kotlin sealed data class that has 4 subtypes: uninitialized, loading, success, and fail. And it's generic on whatever your success type is. We're going to set it to uninitialized, and then we're going to change our getExcited function. So instead of just adding an exclamation point, we're going to execute a network request. For the sake of this demo, title request.create creates an observable of string. It could be from a database, a network, whatever you want. Now, execute is an extension function built into Maverick on observable of t. It will then map an observable stream by starting by emitting loading, and then it'll map on next to success and on error to fail. So in one line of code, we now have the entire state of our request, whether it be loading, success, or fail. And you can see now in our build models, instead of calling state.title, we invoke state.title. Invoking async returns nullable of the success type. If it's successful, it'll give you the value. If it's not, it'll return null. This makes it really easy to just write code that works. And here we have, if the title is null, we'll show the loader, and then return. If not, Kotlin will smart cast that title to non-null string, and we can set it as the title of the header. And that's it. Pretty simple. We no longer have to worry about subscribe on. We don't have to worry about unsubscribing, because Maverick will also dispose of all these disposables and uncleared of the view model. And in your fragment, it's lifecycle aware. So it'll only emit changes when your fragment is started. You'll notice that none of this code has any life cycles because of that lifecycle aware part of it. Almost all of that code that you saw runs off the main thread. Even build models runs off the main thread because in the latest version of Epoxy, build models is async, as well as all the diffing. So what I did talk about yet is that Epoxy in the background will take that model, that header model, that's not the view itself, that's just a data representation of the view. It will then run a differ on all the models that you return from build models, and only dispatch the recycler view changes for the views that actually changed. So you actually get lazy loading, and you get partial updates of the UI. It's also built on top of recycler view, so you get things like animations, preloading, and anything else you want out of recycler view out of the box. It's really easy to incrementally adopt, right? That's why it's taken off at Airbnb. It's a huge code base, but at the end of the day, it's just a fragment. It's just Kotlin. We're not trying to boil the ocean here. We're just trying to make it easy to do what you want to do. It even handles complicated cases like process restoration. And it's used everything from simple static screens to some of the most complex screens in the app. One of our internal projects converted to Mavericks, and it went from 2,400 lines of code to just 600 for the exact same functionality. In addition, we've recreated the Google architecture blueprints to-do app in Mavericks, which is on our open source repo, and is about half the number of lines of code as any of the other implementations, again, with the exact same functionality, same UI, same everything. And so with that, that's Mavericks. Now you know about where we were at Airbnb with cross-platform, we learned about React Native, and we learned about how awesome Android is and how we've taken some of our learnings to make Android even better for the future. So I want to thank you. I'm going to stick around after. We have just a couple minutes left here. We also have lunch, but I'd love to meet all of you later today and at the rest of the conference. So thank you.